All right, Mr. Ahmed here for day 5, our final day of factoring. Goal for today is to actually solve the quadratics in factored form. So a couple things here, just a couple warm-up questions that are going to lead us to where we're headed. If x plus 4 has to equal 0, we're going to solve this in our head. What does x have to be? Well, what plus 4 is 0? X has to equal negative 4. If x minus 7 has to equal 0, the solution is positive 7, because 7 minus 7 would get us 0. Now this one's a little bit tougher. I can't really solve this one in my head, so I'll set up the equation, or it's already set up, sorry. So I'll subtract 3 from both sides. The 3's will cancel, and I'll be left with 2x equals negative 3. From there, we would divide both sides by 2, and we would get x to equal negative 3 over 2. That would be our solution. And same type of thing with this one. I need to actually solve it, so I'm going to add 4 to both sides. And I get 3x equals 4, divide 3, and x would equal 4 over 3. That would be my solution. The zero product property states anything times 0 is equal to 0. So when we solve quadratics, we are going to set the equation equal to 0, all right? And then we're going to find out which values make it true. So if it's already in factored form, it's fairly straightforward, all right? If we have something in factored form, we have an a and a b, these things are being multiplied together. If this value inside the parentheses is equal to 0, whatever a is, guess what? The whole equation is going to equal 0, so it's true. If whichever's inside these parentheses is equal to 0, then 0 times no matter what this is, it's still going to equal 0. So our two sets of parentheses, we just need to figure out what value makes what's inside of it equal to 0. So I need to know x minus 4, that's what's inside of it. What makes that equal 0? Well, x would equal positive 4. So that's one of the solutions. The other solution is when x plus 2 is equal to 0. For x plus 2 to equal 0, x has to equal negative 2. Okay, this one's a little bit tougher. All right, it's in factored form. I should put this one, no, I don't need to put that in parentheses. Well, I guess I will. First one, what value makes 2x minus 6 equal to 0? So this one I gotta solve, all right? I gotta add the 6, and I get 2x equals 6, divide 2, x has to equal 3. This one I can look at in my head. What value makes x minus 1 equal to 0? Well, positive 1. So the other solution is 1. Okay, now, after a while, we try not to have to rewrite these equations each time. We should just be able to look at this. M minus 3 has to equal 0. Because if this whole value is 0, the whole thing's 0. So m would have to equal positive 3. What value makes this set of parentheses equal to 0? What plus 12 is 0? Well, m would have to equal negative 12. Similarly, what value makes the first set equal to 0? Z has to equal negative 9. And the other set, z would equal 1. So most of our quadratics are going to have 2 solutions. Okay, most will have 2. So, do these problems above look familiar? Well, they are factors of a quadratic. Okay, so it's already factored form. So now we're going to factor and find our solutions. Keep in mind, the first rule to factoring is always to look for a GCF first. So this one has a GCF, which is 2x. So if I take out a 2x, left inside would be x plus 4. And it's equal to 0. Okay, we always have to have the quadratic equal to 0. So this one's a little bit different. 2x, okay, 2 times what, 0? That's one of our solutions, is x equals 0. Because 2 times 0 is 0, then when I multiply this by that value, no matter what it is, I'll still get 0. And then inside our other set of parentheses, x plus 4 has to equal 0. That would be x equals negative 4. Those are our 2 solutions. All right, factor in this one, no GCF. Okay, well, let's see. A couple things. First off, I do want to state, I got to backtrack. We have to make sure that it's equal to 0 before we start factoring. Okay, this one's already says equal 0. This one said equal 0. This one says equal 0. So we're good to factor. So factors of the last term that add up to the middle term. And we have negative 18, so that has to add up to 3. So that would have to be a 6 and a negative 3. So factored form. Set up our two sets of parentheses equals 0. X plus 6, x minus 3. Now we're looking for our two solutions, so it's one more step. When is x plus 6 equal to 0? When x is equal to negative 6. And when is x minus 3 equal to 0? That's when x equals positive 3. We found our two solutions. All right, this is the tough one. Have to use the AC method. 3 times 8 is 24. Factors of 24 that add up to negative 14. Well, that has to be negative 12 and negative 2. So rewriting the middle term, 3x squared minus 12x minus 2x plus 8 equals 0. GCF of the first two is 3x. Left inside would be x minus 4. GCF of the second two, negative 2. Left inside, x minus 4 equals 0. So rewrite the outer two terms, 3x minus 2. The common set of parentheses is x minus 4 equals 0. So this one's tougher. All right, when's 3x minus 2 equals 0? That's one I need to write down. Add our 2. 3x equals 2. Divide, and x is equal to 2 over 3. So that's a tough one. Okay, I have to divide it. This one's easy. When's x minus 4 equal to 0? Well, that's when x equals positive 4. So we found our two solutions. That's as hard a one as you will see. Okay. All right. So we're doing a few more of these. Okay. All right. Let's see. It's equal to 0. Is there a GCF? Yes, there is. 3x. Left inside would be x plus 6. Still equals 0. First solution, outer term, x equals 0, because 3 times 0 is 0. The other solution, x equals negative 6 inside the parentheses. Negative 6 plus 6 is 0. First step, is the equation equal to 0? Yes, it is. Next step, factors of the last term that add up to the middle term. Boy, a negative 3 to add up to negative 4. Negative 3, negative 4. I don't think I can do that, because we have a negative 3 and a negative 1. That would add up to negative 4. But currently the way it sits, this won't work, so I'm going to change this to a plus sign. Okay, we'll call that a plus. That way we can use a negative 3 and a negative 1. Otherwise, we'd have to say can't factor, but I don't want you to have that one. So, negative 3, negative 1, so x minus 3 and x minus 1, because negative 3 times negative 1 is positive 3. And negative 3 plus negative 1 is negative 4. So our two solutions, what makes it equal to 0? X minus 3 equals 0, x has to equal 3, and x equals 1. Found our two solutions. We got them. All right, on to the next one. It's equal to 0. So now we have to factor this. So when I factor, let's take a look here. Factors of the last term that add up to the middle term. So factors of 20 that add up to negative 12 looks like negative 10 and negative 2. So x minus 10, x minus 2 equals 0. Two solutions, x equals 10, x equals 2. And I got carried away there with my circle in there. That was a 10. All right. Is there a GCF? Hint, yes, there is. We can factor out a 2. So left inside would be x squared minus 9x plus 14 equals 0. Now I can factor the trinomial, two sets. The 2 is still there. So factors of 14 that add up to negative 9 are negative 7 and negative 2. So it's x minus 7, x minus 2. Our two solutions. There's no x out here. Okay, so I can't just say it's 0 because there's nothing being multiplied by the 2. So we just need to know when x minus 7 equals 0, which is positive 7, and positive 2 would be our two solutions. Okay, for the challenge problems, I think video's at 9 minutes. Well, I'm going to leave the two challenge problems off. All right, honestly, we aren't going to do too many of these with the AC method, so we are going to call it good there. and move on to the second half of the video. Okay, the challenge ones are a little bit more difficult than what we're gonna see. If you'd like to do them, feel free. All right, so factoring to solve. So the next step that we're gonna look at here is if it's not equal to 0, all right? In the first two examples here with our warm-up, it's already equal to 0. So I just need to factor. Factors of 10 that add up to 7. 5 and 2. So x plus 5, x plus 2 equals 0. Two solutions. X equals -5, x equals -2. We got them. Similarly, this one's already equal to 0. Factors of -7 that add up to -6 are going to be -7 and +1. So I'd have x minus 7 times x plus 1 equals 0. Our solutions, x equals +7 and x equals -1. Now, if it's not already equal to 0, we need to make the equation say equal 0 before we solve. So in order to do that, I just have to move it to the other side. So I have to subtract 15x from both sides. Put it in descending order. X squared first, 6x squared minus 15x equals 0. Now we start our factoring process just like we had. So GCF first. GCF here is a 3x. Left inside would be 2x minus 5 equals 0. First solution on the outer part. When's this equal to 0? Well, when x is 0. Now I have to solve the other one. 2x minus 5 has to equal 0. Add our 5 to both sides. 2x equals 5. Divide 2, and we get x to equal 5 over 2. So our two solutions, 5 over 2 and 0. This one, bring the 28 to the other side first because the equation has to say equal 0. So I'm going to subtract 28, x squared minus 3x minus 28 equals 0. Now I can factor. Factors of -28 that add up to -3 are x minus 7 and x plus 4. Okay, we had a -7 and a +4. Keep in mind, we still have to solve it. Solutions, x equals 7 and x equals -4. Opposites really are what we're going to see for most of those. All right, challenging one. AC method's going to have to get utilized here. So I subtract 9 from both sides. 8x squared plus 6x, keep it in descending order, minus 9 equals 0. All right, so now I can't factor this one. There's no GCF. Leading coefficient's not 1, so we have to multiply a times c again, like we did with many of our problems on that lesson. Sometimes it might be easier to solve these using the quadratic formula, to be honest. Ultimately, it's up to you guys. I'm going to show you the quadratic formula when necessary. But for now, I'm going to factor. So 8 times -9 is -72. So AC is -72. Now we're looking for factors of -72 that add up to 6. Now, I don't know that off the top of my head. 72 divided by 3, 36. 72 divide 3 is 24. 72 divide... I have to get it to add up to 6. Let's try 6. 6 and 12, there it is. 72 divided by 6. So 6 times 12 is 72. So I'm going to use a 6 and a 12 for it to add up to a positive 6. Well, our 6 needs to be negative because B was equal to positive 6. All right. Now I can rewrite 8x squared plus, let's go minus 6x plus 12x minus 9 equals 0. Factors of the first two terms, the GCF is 2x. Left inside would be 4x minus 3. GCF here is a 3. So I'm pulling out a 3. Left inside, 4x minus 3. We have it factored. So our two sets of factors. Outer part, 2x plus 3. Common, 4x minus 3 has to equal 0. All right, now, for us to finish solving this, I need to solve both these. When's 2x plus 3 equal to 0? And when's 4x minus 3 equal to 0? Since I'm short on space, I'm going to do it in my head. When I'd have to subtract this 3, I'd get negative 3 over 2. All right, you might really need to write that out to solve it. And this one I'd have to add 3, then divide 4. So I would get x to equal 3 over 4. Okay, probably won't see one that difficult either. All right, next one. It's not equal to 0. Bring the 2x over. Now keep in mind x's go with x's. So that has to go with the 5x. So I'd have x squared minus 7x minus 18 equals 0. A little bit easier to solve this one, okay? Factors of negative 18, that up 7, that'd be a x minus 9 and an x plus 2 equals 0. Solve it. X equals 9. X equals negative 2. This one you can take the square root. One thing though, when you take the square root, it needs to be plus and minus. Okay, so you'd get x to equal positive and negative 8. All right, now, how do I see that in factored form? If I brought this over to the other side to set it equal to 0, I'd have x squared minus 64 equals 0. That's the difference of two perfect squares. So when I'd factor it, I'd have x plus 8 and an x minus 8. So our two solutions, again, were our positive 8 and our negative 8. Okay? And last one, I'm going to leave it here. We'll leave the challenge for you guys. We're done after this one. The challenge isn't necessary. So we'll add 1 to both sides to set it equal to 0. We get x squared plus 5x plus 6 equals 0. So factors of 6 that add up to 5 are 3 and 2. So x plus 3 times x plus 2 equals 0. Two solutions, negative 3 and negative 2. Has to be equal to 0, has to be equal to 0. All right, that's it for factoring. Hopefully that's a good review from last year. Have a good one.